Okay, we're going to do a couple of videos on the second half of the 4.5 lesson. You got a whole other set of notes called 4.5 Part 2. And this one's going to require you to be kind of mentally with me and focused. So don't know when you're watching this. If you need to pause this, go get yourself another cup of coffee. Just kind of be ready to roll, have something to write with you. Playing along at home will help a whole bunch. I want to remind you in the first part of the lesson, we started graphing trigonometric functions. We graphed y equals sine x, y equals cosine x. And then we started to take a look at, if we were to call those parent graphs, how can we manipulate or change or slide the way that basic shape sits on a graph. Remember the basic shape, we have a word for it. It's called sinusoidal. Some people just call it a wave. It kind of has this snake up and down form, and it goes forever left and forever right. And here's what we looked at so far. We can throw a couple of other values into a basic y equals sine x function. This a value here is going to impact the amplitude. How high does it go? How low does it go under the midpoint? And so that's impacted by A. We take the absolute value of A. That's the amplitude of our graph. If A happens to be a negative number, remember that we invert or we start kind of upside down the whole graph. All right. The B value that you see that goes right in front of the angle or is times by the angle, that's going to change or impact the period. For sine and cosine functions, regular parent graphs, the period is 2 pi. After a full revolution, remember, around a circle, sine and cosine just kind of start the whole cycle again. So the period is 2 pi, but we can impact that by multiplying some value here. And remember, the b value itself is not the new period, but we do 2 pi divided by b. So that was all in the previous lesson. We're going to throw another curveball in there and talk about how we might take this graph and how we might shift it to the right or to the left, one side or the other. And we have a name for that. It's called a phase shift. All right. You might just say we're shifting it horizontally. It's a horizontal shift or translation, but the name for it is phase shift. And I'm taking a look at your notes. Hopefully you have them by now, but we're going to use the letter C to see how we might impact the phase shift. And so our equation is going to change slightly and look like this. Now, this is not completely unfamiliar to you. You might remember we did parent graphs back months ago and looked at how we change or manipulate. And hopefully remember in the parentheses, that's where we affected a graph, whether it moved right or left, and it worked kind of backwards. If we had a minus sign, it shifted my graph to the right. If we had a plus sign, it shifted my graph to the left. It's going to work the exact same here. Now, here's the thing: the shift, we call it the phase shift, is not just the value C, but it's C divided by B. All right, that part you have to remember, and that part's in your notes. We're always going to use a positive value for B. Just want to remind you of that. But C divided by B, that means we take C after this minus sign. We take just C. We need a minus there, and then we take just C divided by B, and we get the phase shift. And we're going to practice a couple of things with phase shift. I think what you're going to find is the trickiest part is fractions. Some of you do not like fractions. We're going to be doing lots of fractions, so that's why I just wanted your brain to kind of be straight up. I want to graph real quick. I want to just, for now, let's kind of keep A and B super basic. Let's just make them both 1. Let's just graph a regular y equals sine x graph. And I'm going to sketch this out real quick. I want to remind you if the A value is 1, that means the amplitude is 1. It goes up to 1. It goes down to -1. The period on a regular sine graph is 2 pi. And we break that into 4 parts. Remember, I break it in half. I break that in half. And then those are kind of the increments by which I count. So that's 1 pi over 2, 2 pi over 2. This is going to be 3 pi over 2. And finally, 4 pi over 2, which is just 2 pi. And sine, if you recall, starts at 0. And it's not negative, so it's not inverted. I go from 0 to my maximum, which is 1, back to 0 to my minimum, and back to 0. And so that's y equals sine x. If I wanted to stretch this high and low, if I wanted to make it taller, I could change the amplitude. If I wanted to squish it together or kind of pull it wider, I could change the period. But what we're looking at today is taking the whole graph and sliding it one way or sliding it the other way, and that's our phase shift. And so I want to graph kind of on the same thing as this, and I hope it doesn't look too crazy or too busy. Let's do y equals sine x minus pi over 3. Okay, so that looks a little ugly. What that's going to do is it's going to take my basic sine graph. The amplitude hasn't changed. The period hasn't changed. Those are going to be 1 for the amplitude, 2 pi for the period. But it is going to shift this because it's minus. Hopefully, remember, it's going to shift it to the right. And the way I find out how much it's going to shift it is I do C pi over 3 divided by B. Well, my B is just 1. And again, I realized I picked a nice, easy number. Pi over 3 divided by 1, pi over 3. So my phase shift, this whole thing is going to shift over pi over 3. Here's the part where it gets a little bit tricky. I essentially have 5 key points. Remember, I told you always break your period down into 4 parts. And so if I include the very beginning and the very end, I actually have 5. 1, 2, 3, 4, 5. And what I want to do, if I'm going to graph something with a phase shift, I may not want to write these points down. I just want to write them on the side somewhere, because what I really want to see is the points that they shift to. And so right here, this is 0, pi over 2, pi, 3 pi over 2, and 2 pi. And my phase shift, or how much I'm adding or moving to the right, is pi over 3. So I've got to do plus pi over 3, plus pi over 3, plus pi over 3. You get the idea. And so the worst part of this may be just, I've got to add a whole bunch of fractions, and none of them seem to have common denominators. So we're going to have to get some common denominators. And again, I'm going to try to graph both of these on top of each other. So it's going to make my graph really messy. But if you were just graphing this one, it might say in your homework, graph the regular one and graph this one. Just graph the new one, and then just make those the points that you mark down on your graph. All right. 0 plus pi over 3 is pi over 3. And pi over 3 would be somewhere kind of there. So my new graph, instead of starting here at 0, is going to shift and is going to start there. All right, now I have to do pi over 2 plus pi over 3. And I'm just going to do some quick common denominators. 6 is what I'm shooting for. And so this is 3 pi over 6. And this is 2 pi over 6. So I get 5 pi over 6, just short of pi. That's going to be about here. 5 pi over 6. My common denominator here would be 3. So, and by the way, if I could do them all in sixths if I want. I could do them in 3, or you guys are a bright bunch. If I kind of see how much that moves over each time, I can just move it over. This would be 4 pi over 3. I'm just adding fractions. You can take the time to do that on your own. This would be, let's see, 9 pi over 6 plus 2 pi over 6. Hopefully I got that right. 5 pi over 6, 8 pi over 6, 11 pi over 6. All right. I think I did try to do my math really quick, and you guys can try to catch me with any mistake, but 6 pi over 3 plus pi over 3, 7 pi over 3. I think I got them all correct. So just labeling these, again, might be the trickiest part. 4 pi over 3, 11 pi over 6, and 7 pi over 3. And so otherwise, it's the same shape. It's the same process. I have my my period broken down into 4 increments. It's just that we start here and we end here. And still at the first increment, I'm up at my maximum. At the second increment, I'm back at 0. At the third increment, I'm down at my minimum. And at the fourth increment, I'm back at 0. So that green graph is what happened to my basic sine graph when I did a phase shift, when I did minus pi over 3. It shifted everything to the right, and it would continue forever and ever to the left. It would continue forever and ever to the right. These work for sine graphs and cosine graphs, and so you'll get to practice both of them. And that might be the trickiest thing, is just coming up with these increments. What we're going to do is we're going to get a more complex equation. It's going to tell us, hey, give us the amplitude, give us the period, give us the phase shift, and then go ahead and graph it. And so we'll get a chance to work on some of those for homework. We'll get a chance to practice them together in class. I have plenty of practice for us to do. But I'd love you to just kind of take what we've done here. If you didn't write it down, kind of go back and watch again and write it down, and then give it a try. You're not going to know the right questions to ask or what really stumps you unless you give it a try. And like I said, this might be the most complex variation. We're going to look at one more way we can change a trigonometric graph, and it's much more basic, much easier. And so in the next video, we'll be introduced to that, and then we'll practice 1 or 2 where we're actually doing like all 4 things and taking a peek at that. All right.